So if we look at the limits in number 5, I'm going to ask you to try them by yourself. I'll pause the video, put the answers in, and I'll discuss the last two in a bit more detail. So just as a reminder, as n, the variable, the discrete variable, approaches infinity, the slowest to fastest growing functions in order are the power function, exponential, the factorial, and then the fastest growing is this hybrid, variable in the base and in the exponent. Now if we take a look at part G, we see that we have the limit as n approaches infinity of x squared over n squared. This might be a bit misleading. We're so used to limits involving x. But in this particular case, the variable of the limit is n, and therefore x to the n is constant. Sorry, x to the 2, x squared is constant. So if we bring that in front, we are really just taking the limit of 1 over n squared, and like the reciprocal squaring function, that limit is 0 times some finite constant is still 0. But in part H, we have x to the n, which is no longer constant as far as the limit is concerned. So the x to the n has to stay inside. But when we look at it, x can be any real number. N approaching infinity is going to become a very, very big value for n as a starting point for the factorial. Infinity times infinity minus 1, etc. But x to the n is going to be something multiplied by itself an infinite number of times. And we have this idea of indeterminate, infinity over infinity. Which kind of infinity is going to be bigger? Well, even if x is a really, really big number, like a trillion or a million or anything that you want, let's take a million. A million raised to the n over n factorial is eventually going to be a million multiplied by itself an infinite number of times, n times, but n factorial is going to be n times n minus 1 all the way down to 1. If we look at this side of the ratio, we see that the numerator wins, but over here the n is approaching infinity, and so the factorial expression wins. And eventually there's going to be some point where this power function stops winning and the factorial function becomes bigger. And since n is approaching infinity, the denominator wins, and so this gives us a limit of 0. This last question is asking just to recall some basic facts about the series, keeping in mind that the bounds might not always be what we expect. Try to recall these facts. I'll pause the video and then be back in a minute with the solutions. So here are the solutions for the 4 formulas. I've done the direct formula for A and B since we have bounds from I equal to 1 to n. But for C and D, the bounds are a bit different. You might be able to go directly to the correct final answer, but what I did just to show some steps in between is to do a substitution for the upper bound, and then I applied the formula directly for k, and then I back substituted k equal to n minus 1 to get the final expression. I've just showed this expansion of 2k plus 1, substituting k with n minus 1 to get this final answer. So hopefully all of this background will be very helpful, and you'll see it coming up in the upcoming videos on sequences. Thanks for checking out Raelene Math. That's all for now.